because we're delayed. Okay. You guys all here?
I'm all here.
Yeah?
I'm here. Yeah.
Hey. we have a full house. We're all dressed up with nowhere to go.
Right.
Because
the windows are closed.
The windows are closed.
Yeah. We're completely fogged out here. So we're at like what, 95% humidity, 98% humidity?
Yeah, something like that.
98 last time I looked.
Oh, well. So we do have a program for you tonight, and but before we get started, I want to remind everyone that the Chabot Space and Science Center is planning on opening in November to the public. In the meantime, we rely on your donations and contributions, and I want to thank in particular Fremont Bank for their support of this program and others. And if you see fit to donate, we'd appreciate it. And you can hit that donate button on the Facebook page or visit our website at chabotspace.org to learn about donations and membership at the Chabot Space and Science Center. Behind me is Nellie, the 36-inch research reflecting telescope, and that's the scope we use every week for the virtual telescope program. Tonight, she's just going to sit there, and you can admire her from afar because we're not going to be able to open the dome because of the humidity. So we do have some fun, though, tonight from our friend Don Saito, and he has our monthly video on the sky tonight. So, Gerald, why don't you introduce that, and we'll show the people.
All right. Well, Don Saito is a member of the East Bay Astronomical Society. He's also a Chabot volunteer. And every month, Don produces a little video telling us about what's up in the sky during that month. So for August, we have a video to show you here. Bear with me just a second, and I will share my screen, and we'll show the video. There we go. Here we go.
Greetings, fellow Earthlings. Even as the COVID-19 pandemic appears to be winding down, we're still not at the point where we can safely meet inside our amazing...
Whoops.
I think we lost it, Gerald. Why don't we start it again?
All right, let's see here. We'll try this one more time here.
We're waiting with bated breath.
I think we call this technical difficulties.
Yeah, we've been having them lately.
Okay, let's see here. Share with sound. Can you see what looks like the playback?
Yeah.
All right. Yeah. One more time with vigor.
Greetings, fellow Earthlings. Even as the COVID-19 pandemic appears to be winding down, we're still not at the point where we can safely meet inside our amazing Zeiss Planetarium at the Chabot Space and Science Center. While these online planetarium shows are okay, there's nothing like the simulated real thing, which in most cases is better than the actual real thing. Take my word for it. I am, of course, talking about the constellations. There are people, animals, and objects up in the night sky. They've been there for millennia, but most people are unaware of them as they glide by unnoticed, right over our heads every clear night. Until Chabot's reopening in November, we can still use nature's planetarium, also known as the real sky, to step outside, tilt our heads back. I am, of course, talking about the constellations. There are people, animals, and objects up there in the night sky. They've been there for millennia, but most people are unaware of them as they glide by unnoticed, right over our heads every clear night. Tonight, let us explore these objects and characters, and let them become our friends and familiars, just as the ancients did. To start, let's consider the reason we don't see all the constellations at once. The Earth has 4 seasons: spring, summer, fall, and winter. Well, the constellations also have seasons, having to do with the Earth's yearly orbital path around the Sun. I want you to think about that for a moment. The constellations have seasons too. Just realizing this fully can help make knowing the constellations easier. We can only see stars by looking away from the Sun at night, which changes our view of the stars as the Earth makes its orbit around the Sun throughout the year. At this time, we're beginning to transition from the summer stars to the fall stars. Unfortunately, unless you're at a good dark sky site, and if the moon isn't too bright, most constellations will be somewhat hard to see fully. But most constellations have at least a few bright stars to help identify them, and the better your viewing location, the more you'll be able to see. When we were in the middle of the summer season, we only had about 7 hours of night, as opposed to the nearly 10 hours of night during the winter. But as the Earth slides along its path around the Sun, the number of nighttime hours is now slowly increasing. We astronomers like it when we have more time to view the constellations. A good first step to finding the constellations is done by knowing your compass directions. We can easily do this without a compass, using a star grouping that is quite easy to see and most everyone knows: the Big Dipper. If you don't know the Big Dipper, have someone who does know it point it out to you. Around this time of the year, the Dipper is getting a little low toward the northwest, but it's still easy to see with its curving handle and bowl. Take special note of the 2 stars at the end of the bowl. These are called the pointers, because if you take the distance between them and extend that distance out about 5 times their length, they point to this semi-bright star here. Now, Polaris is the only star in the entire sky that stays pretty much right where it is. So no matter what time of night it is, or even what month of the year it is, all you need to do is face that star, and you'll always be facing due north, with east directly to your right, west directly to your left, and south directly behind you. All the other stars wheel around this pivot point, anti-clockwise, making them appear to rise in the east and set in the west. This is, of course, an illusion caused by the Earth's rotation, which gives the appearance that the stars are moving, when in fact it's the Earth that's spinning. If you think of the Earth as a spinning top, and you extend Earth's north polar axis straight up into the sky, it points almost directly at Polaris. Using Polaris, we found all the compass directions. But Polaris is also the end of the Little Dipper's handle, whose official name is Ursa Minor, the Little Bear, a small constellation. It's a bit faint, but from Polaris you might be able to trace its curving handle to its bowl. The 2 brighter stars at the end of its bowl are called the Guardians, because they seem to march around the North Star like protective sentries throughout the night. Starting between the bowls of the Big and Little Dippers, arcing up and over the Little Dipper, we find the tail of Draco the Dragon. He's also got feet, a short belly, and a long neck and squarish head. There be dragons up there. I bet you didn't know that, but now you do. Now, you probably didn't notice that I called the Little Dipper, also known as Ursa Minor, the Little Bear, a constellation, whereas earlier I called the Big Dipper a star grouping. Isn't the Big Dipper a constellation too? Nope. The Big Dipper is what we astronomers call an asterism, which is only a familiar star grouping. An asterism can be part of a single constellation, or it can be made up of stars from more than one constellation, like the Summer Triangle, which we'll get to shortly. The Big Dipper is only part of the constellation Ursa Major, the Great Bear, as seen here. He's starting to dip below the northwest horizon, but as you can see, the tip of the so-called Big Dipper's handle is his nose. The Dipper's curving handle is the back of his neck, and the Dipper's bowl is like a saddle on the bear's back. The Big Dipper is a very handy asterism because we can use it to find the constellation Bootes, the herdsman. To find Bootes, all you have to do is follow the arc of the Big Dipper's handle until you reach the bright star Arcturus, which is in the lap of Bootes. If you saw his name spelled out, you'd want to pronounce it Bootes, but it's Bootes. At this time of the year, he's a bit face down, but he's got a big head, a cap, a body in a sitting position with a leg and foot, and his pipe. A simple shepherd smoking his pipe while watching over his flock. Looking back towards the east, we find the rather faint constellation Cepheus the King. He's definitely upside down at this time, but he's got a triangular crown, a face in profile, a stylish pigtail, and he's smiling, 'cause he's the king. At this juncture, let's turn around and face the southern horizon. This will allow us to see the rest of the night's constellations more easily, like so. Arcing above the southern horizon is a kind of invisible line where all the zodiacal constellations can be found. This line is called the ecliptic, and is also where the sun, moon, and planets move. This is why the zodiacal constellations were so significant to astrologers. Not that astronomy scientists believe in the pseudoscience of astrology. Most do not. But astrologers were some of history's first astronomers, and for their early work we are in their debt. Starting in the east and moving to the west, we have the constellations Aquarius, the water bearer, who still hasn't quite fully risen yet, Capricornus the goat, who currently contains the planet Saturn. If you do get a chance to look at it through a telescope, do it. It's quite amazing. Pictures on the computer or in a book are fine, but seeing it with your own eyes through a telescope is a different, sometimes inspirational experience. Sagittarius the archer with his bow, Scorpius the scorpion with his bright reddish heart Antares, Libra the scales, and Virgo the virgin, whose head is just beginning to dip below the western horizon. We'll only talk about the goat, the archer, and the scorpion tonight, as they are bright enough and high enough to actually be seen. Starting just above the southeast horizon, we find Capricornus the goat, with his horn, head, body, legs, and tail. To the right of the goat, we find Sagittarius the archer. He's a bit faint with his triangular head, quadrilateral chest, and a large lower body with legs and feet. His right arm is holding out a bow, while his left arm is held high above and next to his head, as though he just shot an arrow. Sagittarius contains within him an asterism which is a bit easier to see. It's called the Teapot, seen here. Look for the Teapot if conditions prevent you from seeing the archer in its entirety. To the right of the archer, we find a fairly easy-to-see constellation just above the southern horizon, Scorpius the scorpion, known by astrologers as Scorpio. He has 2 claws and a bright reddish heart, which is the star called Antares. Antares is so named because it's reddish and found close to the ecliptic, just like the planet Mars. Remember, all the planets move only along the ecliptic, and sometimes it brings Mars and Antares into close proximity to each other. Those familiar with Greek mythology will recall that Ares is the Greek god of war, and the planet Mars was thought to represent Ares. To avoid confusing the 2 reddish stars with each other, they called one Ares, also known as Mars, and the other one Antares, not Mars. Oh, those clever Greeks. Leaving the ecliptic and going back to Bootes the herdsman, just behind his head is a pretty little constellation, Corona Borealis, the northern crown, with its semi-bright jewel star in the middle, Gemma. Using the tips of the northern crown as pointers, we can find the keystone of Hercules near the very top of the sky, an asterism, that's his head, with the rest of his body, limbs, and club seen thusly. He looks like he's running along and heroically brandishing a club. Go, Hercules! Trailing behind Hercules, we see Lyra the Liar, which is a small Greek harp, and not someone who tells untruths. It contains one of the brightest stars in the sky, Vega, the first star to show of the asterism, the Summer Triangle, which we'll see in a few moments. To the left of Lyra, we find the constellation Cygnus the Swan, with its bright tail star Deneb, which is also part of the aforementioned asterism, the Summer Triangle. Below both Lyra and Cygnus is the constellation Aquila the Eagle, with his bright eye Altair, which is the third and final Summer Triangle star. And here it is. The Summer Triangle is very easy to see, even in fairly light-polluted skies. It's also a kind of unofficial direction pointer, as it points almost directly due south. And that's it. There are other, smaller, fainter constellations out there, which I encourage you to look for using a good book and maybe a pair of binoculars too. Speaking of good books, I cannot more highly recommend the book The Stars, A New Way to See Them by the author H.A. Rey, who you may know as the same author who wrote the Curious George books. Rey was a scientist who wasn't satisfied with the way modern star charts were drawn. The astroscientists were not interested in the characters, objects, or stories behind the constellations, so for convenience they just connected the brighter stars into weird geometric shapes, slapped on their Greek names, many of which would mean nothing to the common person, and left it at that. That's all fine and well for them, but for us regular folk, we're more interested in the fun stuff. If you really want to learn the constellations, get Rey's book, which can be purchased from Amazon for about $18. I'd also recommend getting a pair of binoculars before getting a telescope. Binoculars are cheaper and easier to use, and there are many wonderful deep sky objects that can actually be best seen with just a pair of binoculars, and they're all noted in Rey's book. If you do want to get a telescope, ask us or research on the web how to make an informed purchase. Be warned, there are a lot of bad telescopes out there with cheap components and shaky, muddy, fuzzy views that will disappoint you every time. A good telescope will inspire you and your children to a lifetime of deep space exploration and an appreciation of science and nature in general. If you're interested in getting into the hobby of astronomy, joining a local astronomy club can be most helpful. Chabot is partnered with the EAS, the East Bay Astronomical Society, which has many activities and resources you'll find essential to help you get started in this amazing and beautiful study of our natural universe. Thanks for watching this video. If you like this content, be sure to click the thumbs up button, subscribe to our channel, and hit the bell notification icon to find out when new content has been uploaded. This will really help our channel to grow, which would make us all very happy. And until we meet again, we'll see you in the future.
All right.
I never get tired of that. I have to mute myself
when Don
during
first
it
was
because I
doing
keep
these.
cracking up.
Yeah, I don't know about you guys, but I'm having a little bit of internet problem here, so, or not sure what.
Yeah.
Anyway,
Well, we all are. We all are a little bit. It's been
Yeah.
a problem.
Yep.
Yeah.
A couple of weeks.
What was I going to say? I forget now. Oh yeah, when Don was first doing these, he wanted to put himself for all of the
Yeah, this is
usual
freezing.
credit things, so like lighting, sound, and best boy and all that stuff. He wanted to have this big long credit thing at the end, and I kind of discouraged him from doing that. So
It's kind of
anyway.
Monty Python-esque. Yeah.
Right.
Kind of.
So anyway, there's a constellation that he didn't mention, but it is up in the sky right now. It's called Ophiuchus. And some of you may be aware that there's been a significant astronomical event going on at Ophiuchus right now. there is a star which is actually quite far away. It's in the constellation Ophiuchus. It's called Rs Ophiuchus, and that star has gone nova. Now, that means that it has had not quite a supernova explosion, but an explosion causing it to become suddenly very, very bright. And I thought it'd be interesting to share a couple of images that I have, just showing you the difference between how it looks normally and how it looks over the last few days as it's undergoing that nova process. So if you guys don't mind me sharing again.
By all means.
Go for it.
Okay, and let's see, I got to find it here. Where is it? There it is. You see that image? Hello?
Yep.
Yeah, we see
okay.
it. Got it.
This was
I
a
lost you
test.
again.
Don't everybody speak at once.
Yeah. So anyway, this is an image of the star Rs Ophiuchus. This was taken a couple of years ago by one of the survey telescopes. So the star that you see right in the middle here, that's Rs Ophiuchus. And this star is 2,200 light years away. It is a giant star, red giant star, that is in a binary system. It's got a small, very small white dwarf star that's co-orbiting with it. So they're orbiting around each other. And what's been going on is that the white dwarf has been slowly pulling hydrogen gas off of the outer surface of the red giant star. And that hydrogen gas goes into orbit around the red dwarf, becomes like a torus of gas around the red dwarf, or white dwarf rather. And that gas slowly spirals in and lands on the white dwarf. When enough of that hydrogen gas piles up on the white dwarf, it gets hot enough to start fusing hydrogen into helium. But unlike a normal star where that fusion process happens deep inside the star, in this case, the fusion is happening on the surface of the star. And that results in a very explosive event. Suddenly it goes many, many times its normal brightness, and it stays that way for a period of several days. It gets very bright, and then it slowly fades out. So again, this is an image of Rs Ophiuchus taken a couple of years ago by a survey telescope. And I've actually adjusted the image a little bit so that it's more or less oriented the same way as the image I took Wednesday night of Rs Ophiuchus now as it's going through the nova event. So here's what it looks like. So compare that to this, and you see that suddenly it has gotten a lot brighter. Just to give you an idea, when it was like this, it was so faint that even in a telescope, the star looks pretty faint. When it's like this, it's actually bright enough to be seen with the naked eye. So this is a huge difference in brightness. And this is, again, caused by that process that I was describing to you. In fact, I've got a graphic here that I can show you. Two stars orbiting around each other, which is very common. In fact, probably at least half the stars you see in the night sky are actually binary star systems, two stars orbiting around each other. One of the stars has grown old and become a white dwarf star. The other star is in the process of getting old. It has swelled up, become a red giant. And when it gets big enough, the white dwarf starts to pull hydrogen off the outer layers of the star. That hydrogen goes into a torus around the white dwarf, and the hydrogen in that torus slowly spirals in and lands on the surface of the white dwarf. Eventually, you get fusion, you get the explosion, and you get what we call a nova. All right, so that's what's going on. And, this has been getting a lot of attention from astronomers over the last few days. I think it was first spotted about a little over a week ago. And in fact, we're going to have a professional astronomer up here tomorrow night. He's going to be looking at it as well with our telescope if the weather cooperates. So anyway, that's just an event that's going on. I thought it'd be interesting to share that with you.
Now, I understand that this particular star does this periodically. Like the last time this thing had burst like this was like 10 years ago or 12 years ago.
Right. That's very common with this type of a nova event. These stars often will do these nova explosions every 10, 20, 30 years for centuries. So that's very common. So anyway, it's a cool thing to see. And of course, as soon as it happens, all these astronomers point their telescopes at it and their spectrometers and so on, analyzing it, studying the composition of the gases that are being blown off and so forth. It's just a way that we learn more and more about how things happen out in the universe. All right?
Great.
All right.
So you mentioned Wednesday night, and the reason you were here Wednesday night, and the reason I was here Wednesday night, is we were hoping to get a look at the Perseid meteor shower. And although not as bad as tonight, we weren't fogged out, but we were kind of clouded out. And it also looks like the predictions of when the peak of the Perseids were, those predictions were kind of off. Yeah. And they were off by one night.
Yep.
And I saw one Perseid meteor. You might have seen a couple more. Those of you on Facebook, if you were fortunate enough to see any, let us know how many you saw. So far, I haven't met anybody who's seen more than one or two or three. But what was interesting is that the next night there was a burst of Perseid meteors, and I have a photograph that was taken that I want to share here. So give me a sec, and I'll share that. And that's called a delayed peak. And it's usually because on the predicted night we're going through a sparse area of the debris field left by the comet that's creating the meteor, that had created the meteor shower.
Swift-Tuttle.
And Swift-Tuttle, that's right. Thank you. I always forget the name. And and the following night, for whatever reason, there was a greater density of that material. So let me go ahead and share my screen now. I've got the picture up. Here we go. So this is a collage of photographs taken at the Otter Creek Research Station, and the photographer, if I can read that, is Jim Hannon.
Look at that.
Yeah.
Yeah, that's amazing.
Yeah. So you could see just how many they were seeing the following night compared to our rather lackluster performance Wednesday night.
Well, I have to tell you a funny story.
Go ahead.
So a couple of months before this, we start preparing here at Chabot a couple of months in advance because we, invite people to come up and watch the meteor with us and everything. And there are quite a few websites out there that are astronomy themed, and they tell you in advance when events like this are going to happen. And I usually research several of them when I'm getting ready for the Perseids or later on the Geminids and so on. And every website that I looked at, and I've got Sky and Telescope magazine and Astronomy magazine, all of them said the peak was going to be on the night of August 11th into the early morning of August 12th. There was one website, which I often use, but it said the peak would be on the night of the 12th into the morning of the 13th. And because it was the only one that said that, I discounted it. I said, well, they must be wrong. All these other guys must be right. So I discounted it, and guess what?
So much for scientific consensus.
Well, You know, I was out in my backyard waiting for the big meteor show to start, and I got to tell you, I saw zero.
Yeah.
Now, on Facebook, I'll have you all know that we had a couple people report seeing some meteors. Sean McLucas saw one, and that's one more than me, Sean. And Cynthia Sheldon saw 5 from Omaha. So you guys get the gold stars or the gold meteor.
All right.
Yeah, I'll say. That was, you said Omaha?
Omaha.
Omaha, yeah.
Okay, but
Yeah.
the question is, did they take pictures? Is
Hey,
there
well, listen.
photographic evidence.
All right.
Will accept all photographic evidence. I got to tell you, I took about 2 hours of images, and I went back and I looked at all of those frames. Not a single meteor. Although when I started reviewing them, I saw this really bright flash, and I said, "Oh my God, I've got a meteor. I've got one of them." And when I zoomed in, it was an airplane flying through the frame.
I'll tell you, after
Go figure.
Considering the results we had this year, I'm willing to accept innuendo as a form of evidence. So I think we'll leave it at that.
All right. All right. Okay. Well, what else should we do this evening? Since we're winging
I
it?
do have. Well, you know, that same night, since we were so devoid of meteors, I spent the evening looking at Jupiter, and it was actually a fantastic night to look at Jupiter. And you had mentioned that you got some beautiful views of Jupiter through our 8-inch refractor Leia, but I also wanted to show off Damian Peach's latest Jupiter that he published, and this comes from the Why Do I Bother department, and I guess his stuff is always
Damien does that.
Damian
Test.
Peach.
yeah. So I am going to show you Damian's latest shot taken August 1st of the planet Jupiter. And he achieves this by, first of all, going to a place where the air is very stable. He tends to go to island locations. He likes going to the Bahamas and places where you have what's called laminar airflow, where the air is not being made turbulent by mountain ranges or other natural features. And then he takes video. And he takes a lot of video. And what he'll do is go through the video frame by frame, taking only those frames that are perfectly sharp. And he'll use those and stack those in order to create these images that would otherwise require a spacecraft to match in quality. So anyhow, the planet Jupiter, I can't say it looked that good through my telescope, but it did look good that night.
Well, you know, as you mentioned, I was looking through Chabot's 8-inch telescope, our classic 8-inch refracting telescope that was built in 1883 and is still an outstanding telescope. And I was looking at Jupiter with it about 2:00 in the morning, Thursday morning, and it looked almost as good as that picture. I mean, I was just stunned by the amount of detail that I could see looking through that 8-inch refractor.
We get 1 or 2 nights like that a year, it seems, that are just spectacular. Yeah.
You know, we tend to think of stuff that was made, 130, 140 years ago as not being very good.
Ancient.
But I'll tell you, that 8-inch telescope, it's Alvin Clark and Sons telescope. Alvin Clark and Sons was one of the premier telescope making companies in the United States during the 1880s and 1890s. A number of famous telescopes were built by Alvin Clark and Sons. And we have an 8-inch refractor that was the original Oakland Observatory telescope. And it's a great telescope. I mean, it's just amazing how good the views are through that telescope, even today.
I'm going to put up a picture of said telescope so people can see what it is we're talking about.
Yeah.
This is off the Wikimedia page, not the Wikipedia page. But let me go ahead and get this. All right, share screen. Here we go. There you go.
Yeah, there it is.
Nice.
Is that Walter Denmead?
That
Yes,
is
it
Walter.
is.
Yep.
It is
Yeah,
Walter.
yeah, yeah.
So Leia sits on top of a concrete pier there that goes all the way through the floor of the observatory to the ground. And that allows the telescope to be vibrationally isolated from the floor of the observatory. So people walking around don't cause the image to be shaky. And you can kind of get that steampunk impression when you look at Leia with all the brass fittings, and the colors that were chosen. The East Bay Astronomical Society rebuilt this scope about 20 years ago, and got it all cleaned up, and hopefully giving it another 100 years of life.
Yeah. You know, you see that short tube that's on top of it.
Oh yeah.
And most people aren't aware of it, but that's actually a camera. That camera was not part of the original telescope. I think they put it on somewhere in the 1920s, and it used glass plate emulsion type plates on the back end. You see a little square frame on the back end of it. And there were these glass plates that were coated with an emulsion. You would insert it into that frame, and then there was a little lever at the back end of the telescope, and you pull on the lever, and there's just a flip down cover on the front of the camera, and that was opening the shutter. And you'd leave that open for several minutes to an hour as the telescope tracked whatever object you were trying to photograph. Then you close that, take the glass plate out, put it in a light sealed container, and take it and go develop it. And that's how they took photographs, 100 years ago. And so we still keep it there just, for demonstration purposes. It's pretty interesting to see, especially how simple it is. And yet they took some pretty great photographs with it.
It's amazing that you would actually open that up and expose a glass plate for an hour or more. Modern digital cameras will essentially capture the same image in a matter of seconds.
Yep.
Yep. Probably here at Chabot, 60 seconds is about the maximum we can expose without overexposing the media. That's how far cameras have come since what is this, 1883 on this.
And the part you're leaving out is that in order to expose that glass plate for an hour, there had to be an astronomer looking through an eyepiece with a crosshairs in it and keeping your target, or at least a star in the target area, perfectly centered in that crosshair, no matter how cold or breezy or antsy or distracted that astronomer might be.
Many cups of coffee he made the mistake of drinking.
Yeah, that's right. We did have a question from Tim Thompson, and nice to hear from you, Tim. Tim is a regular visitor of our program here, and he's with the Mount Wilson Observatory. He said he had always forgets whether our other refractor telescope is also a Clark. It is not. It is a Brashear refractor.
Warner Swayze Brashear.
Yeah, on a Warner Swayze mount.
Yeah. Right, yeah. One of the other interesting things, while we're talking about how we took photographs a long time ago, if you look kind of halfway between the back end of the telescope and the camera, you see a brass tube kind of sticking up. I don't know if you can point that out,
zoom
Richard.
in on that, Rich?
I'm sorry. What do you
point at?
Right there.
Right there.
Right there. Yeah. Maybe zoom in on that if you can. There you go.
There you go. Perfect.
Okay. So what that is, Richard was describing how you had to look through the eyepiece at some crosshairs, and you kept your target star, or whatever it was, precisely on that crosshair all through the night by making little microscopic adjustments to the telescope. you had to be able to see that crosshair. And back in the day, they didn't have nice little LED things and so on within your eyepiece and so on. So what that tube is, you would put a light over that tube, and that tube is like a little light path that goes back down to where the eyepiece is, and it would light up the little crosshairs inside your eyepiece for you.
Wow.
So
That's amazing. I never knew that.
Yeah.
And I'll bet those crosshairs were made out of spider webs too.
You probably
were, yeah.
Yeah.
Yep.
Yeah.
And then after all of that, you've got to take all of those exposed plates and chemically develop them. And that took a while too.
Yeah, one of the unfortunate things about that emulsion too was it was more sensitive to blue light than it was to red light. So that gave
It's like my camera.
Yeah. They had the same problem back then as they have now.
Nothing has changed.
But what that meant is astronomers back 100 years ago, and they were actually taking photographs as far back as the 1880s. They got a distorted sense of what things look like in the sky, because things look, they were getting more blue light than they were getting red light, and blue and green showed up well, but the red didn't show up so well on the emulsion that they were using on these glass plates.
Yeah, Bob Schock just reminded me that the best spider webs for doing those crosshair eyepieces are Black Widow spider webs.
God.
So that, of course, begged the question of who would have accepted the job to harvest Black Widow spider web.
Yeah, I'm sure they had to train those spiders.
I mean, I want to know how that job interview played
got
out.
to be the apprentice astronomer. That's right. This is
Right.
practicum.
Yeah.
Good gosh. Yeah.
All right. Well, so this telescope we call Leia. We give all of our telescopes names. This one is Leia, and it's one of the 3 observatory telescopes that we have up here at the Chabot Space and Science Center. And when we reopen in November, everybody will get a chance to come up and look through this telescope. It is still a working telescope. And when we do public observing on Friday and Saturday nights, this is one of the telescopes that we use. Walter Denmead that you see there is one of our volunteers. He's a telescope operator, and he is one of the many volunteers who will guide you as you look through these telescopes. So,
It's a lot of fun.
tuned.
Yeah, it's not only a lot of fun, but the images are amazing. I mean, the best image of Saturn I have ever seen has been through that telescope.
Me too.
And,
I agree.
As of Wednesday night or early Thursday morning, the best image of Jupiter I've ever seen was through that telescope. And I'm sitting here in front of a 36-inch reflecting telescope that ought to give much better views of Jupiter, and yet those guys back in the 1880s, they knew what they were doing.
They did. All right. That was nice.
And you know why they were so good at it? Because they didn't have computers then.
Yeah.
Probably relied upon those advanced slide rules.
All right. Well, what else we got to talk about?
Well, maybe we should take some questions and see if anybody's got any questions that they might want to ask about the topics we discussed tonight, or really anything else about the night sky. And we're watching Facebook and YouTube, and there's 4 of us here, so I'm sure we can make something up.
Before I make anything up, though, I have to say hi, Nancy. My sister is watching from Lancaster, so a shout out to my sister. She'd probably get me if I didn't say that anyway.
Oh yeah,
Yeah. So for those of you that may have tuned in a little bit late, we are not observing with our telescope tonight because we are completely fogged in here at the Chabot Space and Science Center. So, they don't call it Fogust for nothing.
Yes.
So,
somebody did ask the question. Kashish wants to know when the next meteor shower is, and I would probably want to say the next major meteor shower. which I would presume you'd consider maybe the Leonids to be the next major one, but there is another one in between. But if we have a good Leonids meteor shower this year, you can expect to see that on November 17th. And John and I were commenting. Yeah, I know. We always doubt it. John and I were commenting, though, that the best meteor shower we ever saw was the Leonid meteor shower from like 2002, 2003.
The problem with the Leonids is that the stream of particles left behind by that comet it's not spread out evenly along the entire orbit. It's clumped together, so that once every 33 years, we get a really spectacular meteor shower. And for those of us who've been here at Chabot long enough, we all remember back in 2002 when the last time we passed through that dense clump, and all other meteor showers since then just don't compare. And unfortunately, it's only once every 33 years. The rest of the time, the Leonids are kind of a disappointment. So the next really
and they tend to be not very bright either. Yeah.
The next really prominent one is the Geminids in December. But there are some other, weaker meteor showers between now and then, and we'll try to let you know about them. But the two that consistently show a lot of meteors during the year are the Perseids in August and the Geminids in December.
And Kashish wants to know, can he see it from India? Because that's where he is. And of course you can, because we travel through the cloud of debris left over from the comet that formed that meteor shower over a period of days. So even though you may not be able to see it during the peak, you should be able to see parts of the meteor shower. And you just got up in the early morning usually, and patiently look up, and hopefully you see some.
Yeah, so very early morning.
I just looked up the Geminids, and so mark your calendars. December 4 through the 17th, you'll be able to see those meteors. The peak will be on December the 14th, and as Gerald said, at very early, 3:05 a.m. on December the 14th.
Yep.
Really, that's actually kind of late. Typically, it's closer to the 12th or 13th. But it varies. It varies from year to year.
Yeah.
All right.
And actually, they're predicting 127 meteors per hour. So could be a really nice show if you have a dark sky location or no fog.
What's the moon like on that night? Did you check that?
No, let me check here.
I'll bet you it's going to be pretty good.
Yeah, Alan was mentioning that the Perseids had the outburst yesterday. Yeah, we showed photos of that a little bit earlier, Alan.
Yeah.
We're late to the party.
Yeah, it says the moon will set, it looks like, at 3:06 a.m. So it should be setting just at the peak.
No, so it'll be waxing. Oh, no.
It'll be waning at that time.
Waning gibbous, yeah. So it'll be setting just about at the peak, which you'd like it to set a little bit before then, but
that's right.
Let's take what we can get, right?
Right.
Yeah, right.
So somebody asked about whether we can somehow put a fourth telescope up here at Chabot. Well,
I know of a 70-inch coming available.
Yeah, right. Yeah, we
just had a discussion about that earlier, didn't we?
Yeah, we don't really have a lot of room for another full-size observatory. We do have several small portable telescopes that we often set up out on our observatory deck. But installing another full-size observatory building is probably not going to happen here at Chabot, unless somebody wants to donate a lot of money. Yeah,
that's right. That's always the first requirement. Gerald, this looks like one for you. Erica wants to know about moonrise and moonset and how that's determined and how it relates to the phases as well.
Well, moonrise and moonset, there's actually two different motions going on as we see the moon moving across the sky. One motion, the main motion, is caused by the rotation of the Earth. So as the Earth rotates, the moon appears to be moving across the sky from east to west, just like the stars move from east to west and the sun moves from east to the west in the daytime. So that's caused by the rotation of the Earth. But the moon is orbiting around the Earth, and it's actually orbiting from west to east. So it takes about almost a month for the moon to make one complete orbit around the Earth. So its motion west to east is much slower than its motion east to west. But from one night to the next, it changes position relative to the background stars. In fact, even during the course of the night, it changes position a little bit. But from one night to the next, there's a noticeable change in the position of the moon relative to the background stars because of the moon is orbiting around the Earth. Now, depending on where the moon is in its orbit, its angle between the sun, the moon, and the Earth is changing as it goes around the Earth. And that's what causes the changes in the phases. So if you can imagine when the moon is in a position such that the sun, the moon, and the Earth make a right angle. So I'll kind of draw this out here. So you got the sun out here, the moon, and the Earth, and you got a right angle here. From Earth, we see the moon as if half of the side facing us is lit by the sun. So we call that a quarter moon. And that happens twice, when the moon is on one side of the Earth, and then approximately 2 weeks later, when the moon is on the other side of the Earth, we get the quarter moon. It's either first quarter or last quarter. When the moon is directly opposite the Earth from the sun, then we get a full moon. And when the moon is on the same side as the Earth as the sun, we get a new moon. So again, it takes, depending on how you want to measure it, it takes either 28 and a half days or 29 and a half days. Relative to the stars, it takes 28 and a half days for the moon to make one orbit around the Earth. Relative to the sun, as viewed from the Earth, it takes 29 and a half days. So the time between full moons is 29 and a half days. But that's because the Earth itself is moving around the sun during that 29 days. So the position of the moon when it's at full is slightly different when measured against the background stars, which is getting way more complicated than I need to be. I'm going to do a lot of hand waving.
Yeah, you're building a house of cards here.
I know. So anyway, there's two motions that you got to think about. One is the orbit of the moon around the sun, which causes the moon to slowly change position relative to the background stars, which we see that change day to day. And that's all predictable. The time it takes the moon to orbit around the Earth is very well known. So we can, mathematically calculate exactly where the moon's going to be on any given night. And then, of course, over the course of the night or in the daytime, you can see the moon sometimes in the daytime. The moon is moving from the east to the west because of the rotation of the Earth. And so when we combine those two motions, we can use that to predict what time the moon will rise, what time the moon will set. And that's, whether the moonrise happens in the daytime or the nighttime, or moonset happens in the daytime or the nighttime, that's actually related to the phase of the moon. When we have a full moon, the moon rises at about the same time as the sun is setting because they are on opposite sides of the Earth. When it's a first quarter moon, the moon is at its highest point in the sky just as the sun is setting, because again, we got that 90-degree angle, moon, earth, sun. And so
or in other words, it's the moon is rising when the sun is close to noon.
Exactly right.
Okay.
So all of this is very well known. We've got the orbit of the moon calculated down to the fraction of a second. And so we can calculate, literally years in advance on what day, on what time, and even where along the horizon the moon is going to rise or where it's going to set. So that's, one of the great things about astronomy. They were actually able to do this kind of very basically 1,000 years ago.
Hey, we got a good question. Getting back to meteors and meteor showers. John asks, doesn't the comet debris that causes these various meteor showers dissipate over the years? Yes, it does, but there's a lot of it there.
But what happens is each time the comet comes around, and like the comet that causes the Leonids that we were talking about, it takes 33 years to orbit the sun. So when it's far away from the sun, it's just a big lump of ice with a bunch of dirt and rock embedded in it, way out there, and it's not doing much except moving along in its orbit. But when it comes in close to the sun, it heats up. And when it heats up, the ice, it evaporates in a process we call sublimation. It turns into a gas. And as it does so, it releases all that embedded, little pebbles and grains of sand and so on, which then trail behind the comet as a tail. That is where all these particles are coming from. And each year, the comet comes around and it releases this burst of particles. It does this every 33 years. And then that burst just sort of stays together. And we pass through it every 33 years. So.
And not only that, the debris field itself is in orbit around the sun. So It's constantly moving. Right. We're not, every time the Earth passes through that, it's not passing through the same exact spot in the debris field, so there's still plenty of debris there to cause the showers.
Right.
Yeah, we're punching holes in the debris field, but it's a different part of the field every year.
Yeah. And one of the things that you got to understand is when you see the comet or the meteors coming at us, when you stay up and you're sitting out there at 1 o'clock in the morning, you're watching the meteors. They can appear in any part of the sky. There'll be long streaks across the sky. But if you follow the line of each streak back, they all seem to converge in one point, what we call the radiant. And the reason they do that is because that is the direction that the Earth is moving in its orbit around the sun. So during the Perseid meteor shower, the Earth's direction of motion through space in its orbit appears to be toward the Perseid or the Perseus constellation. So it makes the meteors appear to be coming from that direction. It's kind of like if you've ever driven through snow, the snow is falling straight down, but if you're driving, it appears to be blowing at you. And it's really because your car is driving through the snow. And the same thing is true with these meteors. They're in orbit around the sun, but the Earth is driving through that stream, and that makes it appear to be coming at us from the direction in which the Earth is going. All right.
That was
a good question. Yeah.
And let's see, we have another one from Steve who missed the introductions and wants to know who Rick Taft is. Where is he? He's sitting by a telescope.
We let anybody in here.
Yeah. Well, so we're all in the same room here. And the telescope that's behind Rick is the same telescope that's behind Richard over there. And it's in front of me. You can't see it from my camera, but we're all right here in the same room.
Yeah.
Yeah.
So Lynn
There we go.
McRae asks about how much would another telescope cost? Well, Lynn, how much you got?
Right. Sounds like an offer to me.
Just to put it in perspective, the telescope behind us here, we got a good deal on. We actually got it for less than $400,000. But if you were to go out and want to buy one of these commercially, back in 2003 when we got it, it would have cost you right around $1 million, and that would have got you the telescope and the mount. You have to put it somewhere, so then you'd have to build a building around it, the pier and all that stuff. So you're talking easily $1.5 million, and that was 18 years ago. So today it would probably be more like $2.5 million to build a telescope this size. The bigger the telescope, of course, the greater the cost. The more sophisticated the telescope, the greater the cost. There are telescopes out there that are easily $100 million telescopes, some of the really big ones, But then if you want to buy your own telescope, you can get a really nice one for $500 if you don't mind having a non-motorized telescope. Or if you want to get a really sophisticated motorized telescope, you're talking somewhere between $2,000 and $5,000 or more, depending on how sophisticated you want to get.
And how big?
Yeah.
Right.
Yeah. There's on August 27th, we're going to have an event up here at the Chabot Space and Science Center called Sunset Science. And we will be using the telescopes that night. And it is a ticketed event. You can come up and look through the telescopes and so on. And one of the Chabot volunteers and EAS members is a guy named Jared Wilson. And he's going to be bringing his telescope and mount up here. And Jared is really into this and doesn't mind spending the money to get really good quality. When you get up here and you look through his telescope, keep in mind you're looking through about $30,000 to $40,000 worth of telescope, mount, and camera, computer all together, somewhere in that neighborhood. So, it depends on how much you want to spend.
Yeah,
it's one of those hobbies that can go horribly wrong.
Right.
Yeah, that's true. But everybody has a camera, whether it be a cell phone or a DSLR. And you can take some amazing pictures of the night sky of the Milky Way, actually, with a DSLR. You don't have to have a large telescope just to start out. As we talked earlier, probably the best optical device that you can have if you're just starting out is a good pair of binoculars. But if you have a camera, short exposures on a tripod will give you some amazing views of the night sky. It's a great way to get started.
Great.
Tim Thompson pointed out that the James Webb Space Telescope was a steal at $10 billion. I hate to say this, Tim, but I think the price has gone up from there.
Yeah.
All right, gents. Well, we've managed to fill an hour.
All right.
Without even having a night sky to point
without
the
the
scope
telescope.
without the telescope. So
I got one last question, if I can answer that.
go
We have
ahead.
enough time.
Sure. Go for it. Yeah.
Frank asks, he's going to Yosemite next week. Wants to see the Milky Way core. I'm not sure about what he means by the core, but he has an 8-inch Celestron.
Yep.
Will he be able to see it from Glacier Point?
Well,
Yeah,
you'll be able to see a lot of the nebula that are in that vicinity. Look for like the Swan and the Trifid Nebula and the Eagle and the Lagoon Nebula. Yosemite is a great place to observe those, and an 8-inch scope is absolutely perfect.
Plenty, yeah.
So
if he's suggesting that he might be able to see the actual central core of the galaxy, that's another story that's kind of blocked by gases and dust and stuff. But should
But
be
all
able to
these
see.
things we've described are in that direction.
Yeah.
So they're
Yeah.
all in the southern sky. From Glacier Point, it'll be in the southern sky, just above the horizon. That's the direction
Yep.
of the center of the Milky Way galaxy. All right.
Have a
Looking
good trip.
south, right?
Yeah.
Yeah.
Right.
Yeah.
All right.
Okay.
Well, thank you, everybody.
See you
Join
all
us
next
again.
week, 9:00. Remember,
don't forget-
Right.
Okay.
Okay.
Yeah.
Don't forget to go to the Chabot Space and Science Center website, chabotspace.org. Sign up as a member or make a donation there. We would really appreciate it.
Sure would. Yep.
All right. Thank you. Good night,
All
everybody.
right.
Thanks,
Good
everybody.
night, everyone.
Bye.
Take care.
Good night, all.
Excuse me.